Hi students, this is JV sir. Welcome to Abhi online classes. These classes are specially designed and updated for the requirements of the entrance examinations like Neet and JE mains. Brush up your concepts to get best rank in Neet and JE mains by following these classes regularly. These are chemistry classes meant for NEET and JEE mains aspirants. The aspirants of NEET and JEE, in this session, I am going to explain about the solid state. The radius of a divalent cation A plus 2 is 94 picometers and of divalent anion B minus 2 is 146 picometers. The compound AB has the compound AB structure is looks like in AB's crystal structure. In AB crystal lattice, the divalent A plus 2 cation radius becomes equal to 94 picometers and that of B minus 2 divalent anion is 146 picometers. So the structure of AB crystal becomes that is the radius of divalent A plus 2 cation and B minus 2 anion ratio becomes equal to 94 by 146. It will gives the 0.643 picometers. That means its ratio is like 0.643 means the radius ratio becomes equal to, the radius ratio lies between 0.414 to 0.732 means its coordination number becomes equal to 6 and the structure becomes equal to octahedral, and this is looks like rock salt type of structure. Rock salt type of structure means NaCl type of structure is there. Its coordination number ratios are for cation and anion is 6:6 and this bivalent cation and bivalent anion radius ratio is 0.643 means it lies between this radius ratio. That's why it is looks like rock salt type of structure. Once you observe this limiting radius ratio, coordination number, shape, examples table. In this table, the last but one is 0.414 to 0.732. That is the limiting radius ratio. It gives a coordination number 6 octahedral and the shape becomes equal to sodium chloride. Example is like this. You go through this table also. The number of tetrahedral voids per unit cell of HCP is, in hexagonal close packed structure, the number of tetrahedral voids per unit cell is, in any close packed structure, Z is the number of atoms per unit cell and it contains two types of voids, that is tetrahedral voids, that is 2 into Z number of tetrahedral voids are present, and octahedral voids or Z number of octahedral voids are present in any close packed structure. Come to this HCP structure. This structure is looks like in this structure, arrangement of atoms at the respective lattice points are like this. In this HCP structure, the number of atoms per unit cell Z value becomes equal to 6, because the atoms are present at these corners and also at the two opposite center of the faces, and the second layer atoms are present at the voids of the first layer. Basing on this, the number of atoms per unit cell in HCP lattice is 6. So it contains the number of tetrahedral voids becomes equal to 12, and the number of octahedral voids becomes equal to 6. In this manner, for other close packed structures, for a simple cubic structure, the number of atoms per unit cell becomes equal to 1, and for BCC structure, the number of atoms per unit cell Z becomes equal to 2. It contains two types of voids, that is tetrahedral voids becomes equal to 4 and octahedral voids becomes equal to 2. And for face-centered cubic structure, the Z becomes equal to 4 and it contains the tetrahedral voids as 8 and octahedral voids as 4, depending upon the Z value. Z is nothing but the number of atoms present in a unit cell. That is, in these 4 close packed structures are like this. Once you observe the HCP structure, here the positions of lattice points are like this.